Okay, we are once again having a conversation today about LLMs. This is really I would say, the ultimate one that isn't really tied directly to our product strategy, which is, so far we've kind of talked about where LLMs came from, what they are, what they're good at, what they're bad at, how attackers are going to utilize them or potentially attack them. And now we're going to have a conversation about like defenders using LLMs. Again, distinguish this between defending LLMs from attack. That's not what this session is about. It's about how defenders utilize LLMs to really upscale, up-level the SOC and make the defenders basically punch above their weight. As usual, I have Sohrob Kazerounian with me, and I'll pass it on to you as a starting point to kind of do maybe a little bit of a mental jog on what we've talked about so far.
Yeah, just to sort of, especially because it's been a minute and this is the last, sort of session on this, just to, really hammer home the point, what is the LLM, what is it doing, how does it function, how does it work? The high level sort of, if I had a elevator pitch, the quote I would give you is that an LLM is autocomplete on steroids, right? It's learning to basically, given some input text, what are the likely sequences of characters, words, or whatever that would follow from that input. It's incredible because these LLMs, just by virtue of being trained to do autocomplete, have a remarkable breadth of knowledge, right? And I'll put knowledge in quotes and we can come back to that in a minute. So they have knowledge about a wide variety of things. And another remarkable fact about them is that you can access that knowledge to do things, to ask questions, to ask the LLM to do things. And you can do that by simply instructing this autocomplete model to do it, right? Asking, instructing, suggesting, and so on. Now, those are things that it's really capable of doing. Things it's not really always capable of doing. One, it won't always strictly remain factual, right? It'll hallucinate facts, it'll tell you stories, it'll make up answers to things in ways that are just, detached from reality in various ways. Another thing is that when the LLM looks like it's reasoning, doing logic, thinking through a problem, I know this is anthropomorphizing a bit, but the real issue is that it's not doing it in the way that humans think about when they're talking about reasoning, logic, and math, and so on, right? So it's important to really internalize that idea. And one thing that I think a lot of people sort of need to understand or grok a little in a different way is that if you ask an LLM to answer a question, it's not going through a file cabinet of data it's seen. Here's the semantic, factoid that it's extracted from Wikipedia and pulling that out. This is knowledge that's now somehow embedded in a neural network in a series of weights, right? So if I had a layer of 1,000 neurons connected to another layer of another 1,000 neurons, each of them connected to each other, that's 1,000,000 weights, right? And those weights can be represented by floating point values, 1.75, -3.26, whatever. That's 1,000,000 weights. And ultimately, these LLMs scale up to about hundreds of billions of those kinds of weights, right? You give some input, information flows through the network, and the model gets better and better at changing the weights so that it creates likely outputs given the input. Right? That's how the thing roughly operates.
Interesting thing to internalize is, we talk about large language models, and we talk about billions of neurons, hundreds of billions of neurons, and yet that pales in comparison to the size of the training set. So almost by definition, this is a compressed view of knowledge, which means it doesn't really have a file cabinet, to the point of your metaphor. It doesn't really have a file cabinet of everything it's seen. It has a compressed version of that. So we can't really refer back to, did I see this or not? And I think that the way to kind of think about this is, let's say, our LLM took all of Sohrob's writing from his lifetime of prodigious production of written material, and then was asked to answer a question in Sohrob's style about some obscure topic. And now imagine two parallel universes. In one, based on all of the things, all of the words that Sohrab has ever said, it comes up with a eerily correct answer, even though Sohrab has never been asked this question or has never written on this subject. And we're like, wow, it is a genius. In a in the other branch of reality, it'll just use all of the words that Sohrob has said and come up with an answer that's like factually totally. It's clearly nothing Sohrob has ever said in both scenarios, but in this case, it is so far off base that anybody knowing Sohrob would go, that's like totally crazy, right? And then we would say, well, it hallucinated, right? And it's like, well, you can't have it both ways, right? It's like if you're basically trying to guess at a version of A, you don't have all of reality at your fingertips. B, even if you did, if you ask it to basically guess what a person or an answer to something is that isn't in the data set anyway, and it guesses it correctly, you give it laurels, and if it guesses it incorrectly, you accuse it of high crimes and misdemeanors, right?
Right. And in both cases, in a very sort of strict sense, it's hallucinated, right?
Yes.
Like it's not, to
Both of
your
them are
point, it's not
hallucinated.
drawing.
If it
Here's the
hallucinates
karma.
well, if it hallucinates well, we're like, bingo,
Yeah.
you know. And if it hallucinates poorly, we're like, that's hallucination.
Yeah, exactly. And so this poses a number of really interesting challenges, right? We want to obviously draw on the utility of the LLM. There's a ton of things it can do. We would be remiss not to use those things, right? But also it means that we have to design and integrate those, especially in a domain like cybersecurity, in a very thoughtful and careful manner, right?
I mean, everybody thinks of their space as being particularly important. If I were running a nuclear power plant and using AI on the front end for decision making, I would probably say the same thing.
For sure. On the flip side, if we're making movie scripts, right, we'd give it a little more leeway to
yes.
play with the truth or whatever. But so on the cybersecurity front for defending against attacks and attackers, it's important to note that yes, the AI aspects of the LLM are really impressive. It's wild what they can do, but first and foremost, we should think of this as something that's going to revolutionize UX, right? The way users are interacting with systems is going to be changed in very many ways because of the ability now for the LLM to sit between you and backend data, backend resources, and be a natural language. I can interact and query that data, right? Both the data in the model itself, so I can get it to output structured or unstructured text, data, code, but also as an intermediary to access various other backend data sources, right?
Mm-hmm.
And so essentially, that's the way we should really start thinking about how to integrate the LLM. And, I think one of the first pieces there that comes to mind is obviously we can use that knowledge, that ability to answer questions, to contextualize things, to explain, summarize both natural language text, but also, given some, CSV file, tell me what's in it, tell me, what's there, what do I need to care about, and so on, right? And there are various ways you can sort of make additional knowledge that wasn't necessarily there in the LLM's training set available to it, right? So in a lot of security specific instances, we may want to maintain a data set of, curated things that we think should be up to date, very particularly like, organized, or, this is the way we want to express some knowledge about that security data. And that includes also, for example, proprietary data, right? So fingers crossed, OpenAI didn't train on our knowledge base articles and things that shouldn't have been publicly available. And so we will want, an LLM that's answering questions to users to be able to access, some aspects of, for example, our scoring functions and, our what are these detections doing? How do they operate? What does this mean?
There's also kind of like a timeliness component of this, right? I mean, if the LLM has last been trained in September of 2021, based on data available then, even if our data wasn't proprietary, we would certainly believe that whatever data it might have trained on would be out of date. We've come up with a new, AI prioritization, and it doesn't know about our AI prioritization. And so the ability to kind of graft onto the existing set of knowledge. Again, this is not in the base model. We don't get to go retrain those floating points that are in the neurons, but there are techniques whereby you can take sets of data and effectively, as a sidecar, effectively inject them into the system, where to the end user it is relatively seamless in terms of seeming like it is part of the base model. In implementation, it is not.
Yeah, because of pandemic, dates in my mind are no longer real, but I think Log4j, the Log4j vulnerability blew up sometime after the 21 cutoff date. I could be,
Yeah.
let's imagine it did, right?
Yeah.
You'd want to be able to say, what is the Log4j vulnerability? Does, ask questions about it. So you could imagine
And
a system.
if the LLM just said Log4j, never heard of it, right? It'd be like,
no
okay.
vulnerabilities, you're fine. But we could make CVEs, for example, available to the LLM. If you ask questions about a CVE, it knows to, pull data from this data source, and you have real-time, up-to-date information. Now, one thing that's interesting, our UX team has been doing a number of customer inquiries, and rightfully, customers want references to that data. They don't necessarily want to trust the LLM that it got it right and so on, right? So it's very important to be able to reference and, link to or source, this piece of information comes from over here, right? And doing that is one step of the process, but there are also errors of omission rather than commission, right? It's not just going to get things wrong that you can go and, oh, it said this, but the original text says something otherwise. It'll omit things altogether that it should have included. And those are going to be things that we have to think about, relatively carefully and thoughtfully again, about how do we integrate a question answering system that, if it fails like that, is going to fail in a way that doesn't, trip up an analyst going through an investigation, cause them to do something, horribly wrong.
Part of this is kind of a straight up UX problem, right? I mean, if you think about it, is at the simplest level, if you described this feature as, the oracle of truth, right, versus describing it as a sometimes wrong AI assistant, then people's expectations are fundamentally different. And so a lot of this becomes kind of, and this is true across all the spaces that will use this kind of LLM and generative AI. How do you produce an experience and create an experience that sets the right expectations with the end user? Because we know, it's not a simple matter of, like, if it was a question of us assigning 3 data scientists and nailing the hallucination problem, then OpenAI would have already done it. And like this is an intrinsic problem of the underlying design of the system. So we're not going to solve that problem. We have to basically live with that problem, but then create the right kind of user experience that sets the right kinds of expectations and causes people at some level to utilize these systems, but not to trust them completely to get everything right.
And I think, one of our data scientists, Ben, pointed me to this term that I hadn't been aware of, but defensive UX, right? Designing the system so that those fallbacks are in place. And to borrow a term from Nassim Taleb, anti-fragile. Like, you want these things to be not just robust, but to, fail in better ways than, absent the use of the LLM.
In many ways, I think the generative AI and LLM experience, which is this transformative event, turns into a transformative user experience practice now, right? It's like all of the applications of this stuff are generally in terms of the end user experience, and all the use cases you look at, it's like, how do you create the right set of experiences with the right amount of squishiness in the end user's expectation, and so that you don't become overly reliant on systems that are imperfect, right?
Right. No, it's a careful dance for sure. Yeah. So that's the piece that essentially, we can imagine very straightforward ways where we want question answering systems. We want to be able to explain detections and so on. There's another sort of obvious thrust or tranche of things you might want the LLM to do. And that, again, the phrase generative AI can generate content, text, code. It can do things, right? And so there's another aspect of the utility here where, it becomes clear that for investigations and for response, not just knowledge and questions and data, but for investigating an incident and responding to it, you can use the LLM in ways that, both will up-level your tier 1 analysts, but also speed up things for your tier 3 analysts, right? You can do tedious, mundane tasks, using the LLM, but also get it to do things that were too difficult to do otherwise, right? And so they're
like tedious and mundane, but not easily automatable by something that uses kind of like strict programming, right?
Right. Yeah, and you know, well, just a couple examples, right? One of the things that's both mundane and not strictly programmable is the ability to let users in natural language say, "Hey, what I want to do a search over my data. Which hosts connected to which external domains and transferred more than 5 gigabytes of data." Right? These are natural language questions. Should be, in an ideal world, any AI assistant would be able to take that, convert it to SQL, and then run the SQL, get you the data, right? Even if a tier 3 analyst knows SQL, removing those points of friction, right, makes it so that a system becomes more usable and more sort of ultimately both friendly and provides a utility, right? And so in a lot of these cases, you can think of the LLM as essentially serving as a unified query language to different backend data sources, right? Where that unified query language is natural language.
Yeah, and in some senses, you may need to ask that question of multiple data sources. For instance, let's say you have EDR and NDR deployed, right? So the question that you just asked, there will be the NDR perspective, which will be valid for all of the on-prem and cloud resources that have NDR deployed. It will clearly miss any end user machine that's sitting somewhere at home that is not connecting to either of those networks. And yet you could also ask a similar query of the EDR system, and you could combine those results and create kind of a unified view. So these complex data sets, it's not just that there is a single complex data set that there's a friction for you to learn, but there may be this may in fact be 2 or 3 SQL queries, and then some effort to kind of normalize the results, because let's say the byte counts that come back from EDR end up being strict byte counts, and the ones that come back from NDR in the same data come back as kilobytes. Now it's like, okay, well, there's just like messiness now. You can imagine trying to, as an analyst, write all of that logic and normalize the data. It's not that easy. It's also not that hard. It's just like messy.
Yeah, and the thing is, it'd be easy if you knew ahead of time that this was going to be the case. And if you were always repeating that task, probably you wouldn't want an LLM to do it. But that sort of ad hoc interaction where you're using natural language, take the EDR case. I don't want to remember what CrowdStrike's API structure is, what their data source, using the LLM as a way to abstract that away for me means I don't have to remember that, means I don't have to remember our SQL tables, means I don't need to remember the Lucian query language to call things from, recall, for example, right? And so
also, by the way, the transition from recall to LC39, like all of the training requires, like I'm still conceptually asking the same question. It's now just against a very different set of tables, different query language, everything, right? That transitional experience is just kind of like smooth, right? Because you're just interacting with the system at a natural language level.
Yeah, this is the point on the unified query language. I don't know if anyone else actually out there refers to it as that, but I really think it's the right way to think about it. It's a unified query language. It's natural language, whether for a user might be English, French, German, whatever, but it's very sort of, it's our instinctual how we want to communicate with things. So these are ways that you could use it for investigating, for things that are too difficult, for example.
Again, before we kind of go away from the investigation, I think the other thing that's kind of key to investigation is that it is an iterative process, right? You ask a question, you get an answer, you ask for a refinement potentially, or you riff off of that answer and go someplace else, and then that thing might have been a dead end, and so you come back and then you kind of continue on. And again, the nature of the way these chatbots have been implemented, right, allows for that kind of iterative kind of process of discovery, which mirrors really what you do within an investigation. It's not like, oh, I'm going to investigate this thing, which basically means I'm going to run a single query, and then I get the results back, and it's like nailed it, right? That's seldom the case.
Yeah, in fact, it makes you want to rename XDR to XDIR, right? The investigative piece has to happen. You have a detection. If it was just as easy as responding, whatever, then it means you could automate the whole. But there is this process of discovery and understanding and figuring out what you want to do. And again, it's a lot of fun to anthropomorphize in a similar way to how humans reason about things. There are chain of thought reasoning patterns for language models where because you ask it to break down its reasoning into step by step, it actually improves its ability to answer correctly, right? As it starts generating step one, that becomes part of the context, right? In a similar fashion to as we step through various pieces, context around what we're building up in an investigation will make it likelier that will happen upon a correct answer here.
Yeah, it'll be a cumulative collection of information that you're basically probing rather than a single kind of train of thought, right? Where it's like, okay, I'm just going to ask about refinements of the last thing. Okay, so let's talk about response. I mean, that's kind of like the other kind of interesting place. How should we think about response?
Yeah, so as a thing that's within scope, but also a little riskier, right? So response means the ability to, hooking up the LLM with the ability to do things, right? Shut down accounts and, maybe, whatever other types of response mechanisms you want to make available.
Insert a firewall rule to block something.
Right, yeah, exactly. Yeah. And this is, something that in principle an LLM could write the firewall rule for you, can give you the PowerShell commandlet, and if you create plugins for the LLM, you can allow it to run that PowerShell commandlet. You can allow it to insert that firewall rule. Now, there's this question of how do we defensive UX? Yeah, well, Skynet or the janky version of Skynet that
where you make a mistake and take down the world, basically, right?
Yeah, exactly. But again, the defensive UX piece comes into play here, where if we put a human in that loop at the moment, you can have the thing recommend to you, this is the PowerShell commandlet, either you run this or I run this. But in a real way, you can have it respond to incidents and recommend basically, the rule, that commandlet, the whatever you want to do to shut down an attack in progress, right? And so
there are really two ways of thinking of response, though, right? There is the one-off response. I have this attack going on right now, and I want to respond to it. Give me a strategy for how to respond to it. There, the human can definitely be in the loop. But there's also this notion of, if you think of triage, AI triage as an example, well, not just AI triage, regular triage as an example of this. There is hey, I want to memorialize a decision that I have made, and when these conditions are met in the future, I would like this action to be taken automatically, right? In that case, at the point of the action is taken, the human is clearly not in the loop, right? And really, practically speaking, neither is the LLM in the loop. It's written the rule. The LLM runs at the human's behest. So really, what we're talking about then is, if I, in natural language, stated to the LLM that I wanted to take this action when these conditions are met, like when more than 10 gig of transfer occurs to a particular domain within 4 hours from a machine that is in HR, I would like that to cause the machine to be quarantined, as an example. That would be my English language expression. Now, I could totally imagine the LLM being asked to effectively write the script for that. The human looking at the script, and then the human ultimately taking responsibility for committing that script into the system, which will then execute that script in the future without the involvement of the LLM. The only involvement of the LLM will be that it was a co-author of that script.
Yeah, this is an important point, and you would not want, for example, the LLM to be reading a stream of network metadata, counting, and running the algorithm itself, but using it to help write the rule, to write the algorithm, and then deploying that, at the moment with human sort of intervention and checking and validation. Maybe in 3 to 5 years, we're talking about a world where you would trust it on its own. But yeah, it's certainly human in the loop in that process.
Yeah, and so there it's kind of an interesting point, right? There's XDR, and you suggested kind of XDIR. So the I becomes kind of the manual process whereby an analyst working in conjunction with the LLM does a lot of kind of investigative stuff. The R could be a one-off response, or it could be a memorialized future response. And so in as much as the system is running fully on autopilot, it is doing XDR in the sense that it is running a whole bunch of automated response scripts that are driven by detections across the whole gamut of attack surface. But then humans in the loop continually are improving the system and creating new R's based on new D's and conditions. And so that's kind of the way to think about it, right?
100%. And this question of end-to-end automation, we've seen some startups claiming to be able to do that. It's an interesting demo territory, but not the type of thing that you would trust an LLM to do the, write me the detection rules, then investigate the output of the detections, and then respond to the investigations. It's interesting.
I think, again, systems like this and technology like this, I mean, there's a trust issue, right? Now, does that mean that certain people, certain irresponsible people will turn over the keys to the universe to such a system? Yeah, I mean, humans do stupid things all the time, right? Are we ready, really, in a world like where we actually care about outcomes? Are we ready to do that? No, the technology is not ready, and it's not clear to me, quite frankly, without some fundamental kind of rethinking of the core tech, how we get there, right? Yeah, you can take maybe LLMs and surround them with a whole bunch of other technology, or you have to reinvent at its core what LLMs are. But LLMs by themselves, in this approach that we have, which is where they learn to approximate knowledge, I think you'd be hard pressed to put this into autopilot for anything other than maybe the I feel lucky button on your search engine, right?
I'll give you a little pushback on that one.
Yeah.
So I agree that right now you wouldn't trust current LLMs to do that. I think in 3 years or 5 years, if you saw that LLMs, even if it's still just doing autocomplete, if the steroids have gotten strong enough that autocomplete models are really reasoning in ways that are more trustworthy than humans and more accurate, then the question becomes, in the same way that with autonomous driving and so on, at that point.
Here's a cultural problem. You can prove, I think we could all make the case that if you had self-driving cars, if you really invested in technology and you had self-driving cars, and if all cars were forced to be self-driving, right, there would be less human deaths overall than if in a scenario where you have humans driving the cars. However, that still doesn't mean that when a self-driving car makes a mistake, that it will not be totally culturally be blown out of proportion, even while statistically representing a relatively small subset. And when compared, when compared by a rational human being to the outcomes in the two parallel universes, you would choose one over the other. But that does not mean that culturally humans are prepared. Like when they hand over the keys to machines, they expect them not to just be better than the average human. They expect them to be close to perfect.
Infallible. Yeah.
And
no, I agree, and that'll be an issue.
That's a cultural thing to overcome, which is not necessarily overcome by just statistically, hey, it's better than the average human being.
Yeah, no, I agree with that for sure. And I think that last sort of aspect that you can think of LLMs as being potentially good at, their ability to analyze and reason over things. It's in that place again of you don't want to trust it to do the thing. Don't trust it to analyze and reason and decide, for example, this is malicious, this is not malicious. I'm not going to show you this because I've decided. Right?
I think we can all agree that we would trust LLMs to create fake dance videos for boomers and Gen X who don't really know how to use TikTok.
Yeah. And it will and probably already is starting to, right? But I think, again, to that point of defensive UX, designing interactions where, for example, one of the use cases you might imagine, an LLM can tell you whether or not a script is malicious. Sometimes even when the EDR, like an antivirus model that has been designed to detect malicious activity, might fail, right? But it's also going to miss a lot of things that your EDR is going to pick up. So how do we design a world where you get the best of both worlds without, for example, creating too much noise and so on? So I think that's the real crux of it.
I think we will leave it there. I think there will be a future session. We're currently kind of working on an longer term LLM vision in terms of what we do with LLMs and what we don't do with LLMs within the company. I think there will be a session that we'll do sometime down the road as that gets firmed up. We have some plans for initial implementation, but we really want kind of the big picture of the scope of our ambition to be there. And so that will be a future one a month or two down the road. For now, we conclude this series. Hopefully you will have found this both informational and fun to watch. And shoot us any questions. So Rob and I are always available if you've got questions on LLMs and what they will likely do in certain scenarios. So on that note, I'm going to call it an end to this session.